Hi, I'm Jonathan Billings. I talk using kAFS on Linux for network home directories, otherwise known as AFS. Those guys are still around. Oh. Otherwise known as the only other talk or the other network talk that's not about Swift. So I'm just going to talk about a couple things. Here's just a little summary of the things I was going to talk about. We'll go over some background, what AFS is, in case anyone here has not heard of it or has forgotten. It's been a while. And then I'm going to talk about AFS in the Linux kernel. It is part of the Linux kernel now. Some of the features, some of the systemd issues that we've run into. And then I'll talk a little bit about why we would want to use kAFS and then the future. What is AFS? It's a distributed global file system. It allows you to replicate data across multiple servers. It supports user authentication, has access control lists for managing users and groups. It started as the Andrew file system. I think it was the Vice file system at Carnegie Mellon University in collaboration with IBM, which was then spun off as Transarc, which was then later reacquired by IBM. OpenAFS was released, IBM opened the source to the Transarc client as OpenAFS in 2000. It is 2000, right? Yes. And now the source is managed by the OpenAFS Foundation. AFS runs on top of RX RPC. It's a global file system made up of a collection of cells. The data is stored in AFS volumes, which are served by AFS file servers, and that is a super simplification of how it works. There's a lot of actual different separate servers that run, but that's from the client side, you just think of it that way. It uses Kerberos for authentication, and the paths just appear something like AFS, cell name, and then things underneath there, and I'll give you a little bit of an example later. RxRPC, it's a UDP protocol. It's an RPC service. You can actually multiplex multiple services over a single port. AFS uses Rx for all its services. I don't believe there's anything else other than some small projects that use Rx. The services correspond. There's a service number that's in every single packet that there's a Rx services registry that you can look up what all these services are. Let's see. So this is what the AFS file system looks like. It starts at the top with an AFS. Then there's AFS cells underneath that. I work at the University of Michigan, so I'm going to mention that one. OpenAFS is another one that is there. There's actually hundreds of cells. You can reach them by going, there's a cell serve DB. This is the OpenAFS style of having defining cells locally, but you can also use DNS records. This is the AFS DB record, which no one should be using, but my cell uses it. So that's why I have that as the example. So the cells actually have underneath them AFS mount points. Actually, the cell is a mount point, and each of these are volume mount points underneath them. And then you have directories like my home directory, which lives off the user volume. These volumes so you can see the nomenclature that's used to define the various cell names. There's a root cell, user, user.j, and then user.jsbilin. That's how we do our AFS home directories. And they just kind of appear as local file systems whenever you've got the client running. You could read files just like you would read any other file. One of the things that AFS does, and it's actually kind of cool, and I wish other file systems could do it, is they have this kind of magic @sys. And the sys name is an array of strings. and you can use it to substitute in symlinks and in environment variables to kind of give you some flexibility on a path. And what it does is the kernel automatically substitutes each member of the sysname in that array as a replacement for @sys. I'll show you, and it's really useful. Back whenever AFS was started, there were a dozen different Unix operating systems, and Linux wasn't around yet, so it was that and Windows and later Mac. You could actually have the same path for all of them, and they would use the @sys to go to a different architecture from there. So for example, I'm using in this example, a host name is in my @sys, and I have a little symlink that says, I am host name in there, and you can just cap the thing and it says what the host name is. It's actually really clever, and it's super helpful if you're a sysadmin and you want to give a stable path for everyone so they don't have to have different paths if they're on a 32-bit system or on a 64-bit system or an ARM64 system. You can have uniform paths. So why should people use AFS? It has atomic volume moves. So one of the things that you can do is whenever you have read-write volumes and you've got read-only volumes, you make changes to the read-write volume and you want to put it out there in production, you can release it, and there's going to be a guarantee that there's never going to be a client that's going to see a partial update. There's really strong identity management that's tied into OpenAFS and to AFS in general. It's an open source product, but there's also commercial clients. It supports pretty much all the biggest OSs out there. There's a lot of people using it for that. And there's a lot of collaboration you can use between cells. So for example, I can see into the MIT cell from my home directory. I can see into my cell. I can see into the Orastore cell. And I can use my identity to read and write files into those different cells. However, it isn't widely adopted. It should be, but it's a little complex. It's not something you can just spin up, not yet at least. We're trying to make stuff work with Docker and everything like that, but you can't just export /data as an AFS volume. It's its own protocol, and you would need to migrate the data into an AFS volume. They're like with a lot of other network file systems, it doesn't always support all the various semantics that that local file systems support. So if you're using it as a home directory, it doesn't support something like Unix domain sockets. If you've got an app that's trying to put a socket in your home directory, it just is very sad. At least for OpenAFS, it uses a kmod that's outside of the kernel tree and probably will never be allowed to go into the Linux kernel tree.
Well, if it had a same license, we could have massaged that.
Yes. There's a big discussion as to why that happened, and probably don't have time to discuss it here. But however, there is a Linux client in the kernel right now. It was first introduced 2001 or 2002-ish by David right over here. It initially only supported reading, I believe, and setting up the mounts were pretty manual. There's been a ton of improvements over the last, 2 years, probably more than 2 years. But last 2 years, it's really gotten very useful. And these are the config options that you need to have in your kernel. Fedora has it already enabled. Debian has it already enabled. If you're using Red Hat or CentOS, if you use the EL repo kernels, it's already enabled there. So it's actually already there on a lot of systems. It uses a lot of native Linux kernel features, like the FS cache. It's using keyrings. The kernel trace points, I alone have used this a ton just in the last day, while we were trying to debug issues with doing AFS over the conference Wi-Fi. Because it's GPL'd and in the kernel, it can use the crypto API. And also it uses the dynamic auto mounts, which I'll show in a little bit later. It also uses the key util for storing AFS tokens and the request key system to allow the users to be able to make the kernel open mount points. So this is the systemd unit that you use for getting AFS running on a system that supports it. It's really simple. We just basically have a mount. There's a kAFS config.service that I don't have mentioned here, but it gets the cell information up and ready, or it sets up the parts so it can do the mount points. But yeah, you basically just mount it with the dyn option, and it automatically does all the shows all the mount points. And so you can see right here, this is what it looks like. I kind of put in green the size of the UMITch cell. That corresponds to the quota of the volume. That's one of the differences from OpenAFS. OpenAFS just shows /AFS as a 21 terabyte file system or something like that. Completely doesn't correspond to anything actual and real, but the kAFS does use that. Every single mount point shows up as a separate mount, or every volume shows up as a separate mount. And you can see the quota is there. And also, if you look closely, the volume names for here start with a pound, but my home directory, it starts with a %. And there's a reason why that's the case. My home directory is a ReadWrite mount, because I like to write things in my home directory. But the user volumes don't need to be. They're actually replicated across multiple volumes. And this is kind of what they look like. This is a little bit more what I was talking about. The first read link, you just do read link. That's what mount points look like in AFS. They're just specially crafted symlinks. And they end with a dot, which is fun. And if you evaluate it, like I did right there, now it just shows up as a mount. And then I just grepped it out of proc mounts just to show, yep, there it is. Is that? That might be me typoed. Oh no, see that I didn't actually go into my home directory. The user.j volume is a read-only volume. That's just what it looks like in mounts. And as I mentioned earlier, there's the user's read-only, and the user.jspen is read-write. So this is what the cell is, and you can ignore most of the information. It's just the last 4 lines. You can see that it's actually replicated across 3 different servers. One server has both a read-write and a read-only. And there's a little RW for the read-writes, and the ROs are the read-only. But my home directory, it only has one read-write. Authentication, you have to get Kerberos tickets, and then you run the aklog kAFS. I ran it with Kerberos, so you can see all the stuff about it. And then it stores something in your keyring, the session keyring. And that's what is used to authenticate you to AFS. AFS or kAFS uses FS cache instead of a separate caching daemon. It supports IPv6 when talking to a server that supports IPv6, such as Orastores. I think it's really cool. Each volume is its own mount. I am a sysadmin that uses AFS at my job, and so having it so if someone fills up their AFS volume, then you actually have tools that will tell you, oh, you've run out of space. Previously, your client would just stop being able to write, and no one would know why, but now you can tell. And also, I mentioned earlier, those being able to debug with those tracing things are super helpful, especially whenever I'm trying to figure out why I can't talk to AFS over the network. And also, it does not use any of the PI octals, which has, I guess, been contentious in the past. Okay, so I'm going to have a couple slides about systemd. I'm not a systemd hater necessarily, but I do not necessarily like systemd, especially when we start talking about systemd -- user. I'll just call it systemd user from now on. When systemd user starts, it's actually launched as a child process of the PID1 systemd. It's not launched as part of your PAM stack whenever you log in. So it shares no, it's not a child of your login process. It doesn't have any of the environment variables that are set as part of your login process, and it doesn't share your keyring. So all sorts of stuff happens whenever systemd -- user launches. It reads a bunch of stuff out of your home directory. It tries to put some files in your home directory. And that basically doesn't work if you're using any sort of Kerberized home directories. So we were just talking about SMB. SMB, if you're using with multi-user and you log in, that uses your Kerberos credentials to get into your home directory, and that's all set as part of your login process. Guess what? For NFS v4, SMB, OpenAFS, and also kAFS, it can't read into your home directory. There's this whole process that is launched whenever you log in that can't even read into your home directory. Kerberos has always been a session-based cache. It's always assumed that you're in the session. Systemd, the caches are usually defined by an environment variable, and basically it gets access to it because that environment variable is passed on to child processes. And when systemd user runs, it doesn't have any Kerberos tickets. It can't read into your home directory. It can't write into home. All the services that are launched from systemd user can't see any files. They try to create files and they can't create them. And any of these daemons that are started as part of systemd user can't start. And guess what? Modern Linux systems now rely on systemd user to largely start up parts of their files, part of the user interface. X just crashes. Rootless X tries to save its log files in the home directory .local share xorg. And the first thing it does whenever you try to log in with a rootless X system is X crashes. And the solution that I've had to fix that has been creating a symlink to /temp wherever it wants to store its log file. And then I can log in. Yes, and I imagine he's going to run into all these problems whenever he gets into that. I totally agree. In fact, that's actually where I put a lot of stuff. Yep.
Yeah, but at the same time, it shouldn't be in global scope. It should be in the user subdirectory of the local temp.
Yes. Dconf also and Nautilus crashes. A good example is if you use a modern GNOME system and you log in, GNOME Terminal is not actually a child process of your login server. It is started, there is a GNOME Terminal service that started whenever you first start GNOME Terminal, and all these terminals have no Kerberos tickets. And here you can look at, the first one's an Xterm, and the bottom one is GNOME Terminal. And if you look at it, they don't have the same C group. They're in a completely different C group. And it's a C group that obviously has been titled GNOME Terminal Server.Service, which is nice and repetitive. Yeah, so what's the solution to this? Well, one thing, you can have a easily defined Credential Crash, which I just use the persistent keyring. And as part of the login process, you just basically tell it to import the Kerb5cc name. And that's the command you do to basically tell systemd user to import it from your session. Unfortunately, all these things get started before your CC cache is even initialized, so you have to actually run this after you've logged in and then restart all the daemons that failed to start because they couldn't read into your home directory. Unfortunately, doing that doesn't always work in kind of how Kerberos has worked for the last 20, 30 years, which is a session. You know, hey, I logged into this system, but you know, hey, I'm using my laptop and I'm SSHing into my workstation to grab a file or something like that, and oh no, guess what? My session just got completely hosed because whenever I logged out, I did a kdestroy, and now my entire session can't write, and I can't even use anything in there. Firefox is now so confused because it suddenly can't write to its cache directory. As I said here, multiple logins will cause problems. Also, if you ever want to do something with a different Kerberos credential, you have to go and define a separate CC cache just to use it. And I use that a lot whenever you're doing anything that is not you. For example, I sometimes become my Windows admin Kerberos identity so I can talk WinRM to Windows machines and do stuff like reboot them or something like that. And I don't want to do that as my user ID, and guess what? My Windows admin can't actually talk to AFS, so it does not like that at all. So I have to run it basically in a separate C cache. And kAFS actually has it worse because not only is Kerberos not there, but the AFS token isn't there. That AFS token has a tendency to hang around in this systemd user process. And here you can see the keyring. I did a key control show at S that shows the current keyring session, or session keyring, and the numbers don't match up. So it's a different keyring, because it's a session. And one of the things that systemd-s user does, and it's a neat idea, I admit, is it actually can persist after you log out. So if you've got something that you want to have, like a screen session or something like that, you can run it inside your systemd-s user, and it will stay after you log out. However, if you're using Kerberos and you do a kdestroy, well, it won't work anymore. And if you're doing AFS, you have the same problem. And guess what else happens? When you go and log in again, it'll have those tokens from the last time you logged out. And if you were using a different identity when you had logged out, let's say you're an AFS admin, whenever you were logging out and you left those tokens running in the systemd user, when you log out and then log back in, your user will have, your normal session will have the tokens for your normal user, but the systemd user will be running with the tokens of the admin principal. It's a mess. So what I do, I have this little systemd user session that I have that's not defined in my home directory because it wouldn't be able to find it. It's in etc systemd user. And it just basically runs aklog. It imports the Kerberos or kerb5cc name and runs aklog. And so that's all it needs to do to get tokens. It's not a great solution because, as I mentioned earlier, they persist. Whenever you renew your tickets and your tokens, that doesn't magically get pushed over into it. It's a completely different keyring. So you can renew your Kerberos tickets in your normal workstation, and if you don't remember to also renew the sessions in the keyring that's running in the systemd user, it just doesn't work anymore. And of course, it just breaks GNOME. There's just a lot of stuff that breaks with GNOME, and really the solution that I found was just to disable systemd user completely, and that's the command you use if you ever want to do it. It's kind of cathartic. But unfortunately, if you disable systemd user, Flatpak, it gets really unhappy. GNOME tracker, it wants to run all those things the systemd user processes. For the most part, stuff just kind of degrades naturally into the way it used to work. But in the latest GNOME, if you disable systemd user, GDM just won't even start. Because in the latest version of GNOME, the interface elements, basically the banner And the UI that you use to log into GDM is actually started as a systemd user process of the GDM user that's running the GDM process. So yeah, it doesn't work. So I use LightDM and Mate. So they have not yet succumbed to the systemd fate. So if you are an institution that's using AFS, I definitely recommend checking it out. It's pretty awesome. I believe it's more efficient than OpenAFS. I had a bunch of slides I was going to make about the performance, but unfortunately all the performance tools that I use crash whenever I run it against kAFS, so it's not quite there yet, but I definitely think that it's worth trying. There's definitely less overhead because it is able to use there's kernel threads that are able to talk directly to the crypto layer, as I said earlier. It's able to do some of the things that you can't do in a third-party client. And from my initial testing, write latency did seem to be about 80% of the speed or the delay that you would get out of compared to OpenAFS. So I think it's got some performance work can be done to make it even better, but I think that's pretty good. And the great part is it's already there. You can just start using it. And it's got a nice open license. These are some of the things that still need to be implemented. And I think I took most of these things right from David's slides. Basically, there's more tools that need to be created. FS, VOS, BOSS, PTS. These are all AFS commands. We need to fix the user keyring, maybe use the user keyring instead of the session keyring, or at least give that as an option. And also, I'm going to see, we need to get more distros to turn it on. And, hopefully at some point we'll have support for things like iNotify and extended attributes, and be able to support things like container namespacing. So I want to thank you, David and Jeff for all the help he gave me in making this presentation, and also the OpenAFS Foundation. Thank you.
On someone's home network. I know there had been some work way back when to make it easier, but I don't know if any of that work still exists or has bit rotted.
There's actually a couple scripts for setting it up. One of the projects that I am working on is trying to make it so I can run both a KDC and a cell on my laptop. So I want to make it all kind of like, there's going to be Ansible playbooks that basically will spin everything up, make everything in place, and you'll be able to have an AFS cell. And I'm sure that that will be extendable to have as a client, a small home use.
Did anyone in your group or other people trying this ever contact the systemd or GNOME folks about their creative interpretation of sessions? I know it's not always easy to argue with them, but I mean, this breaks so much thing. I mean, any Kerberized NFS will be just as broken, for example, even if they don't like it.
I mean, we want to use the multi-user SMB, and yeah. Then okay. We actually have an open ticket. We created a pull request, I guess, was it an issue against systemd in their GitHub repo, and yeah, it got repeatedly closed by Leonard.
Yeah, the underlying theory, by the way, I'm Jeff Altman. The underlying theory from the systemd folks is that security is the concept of sessions, and in the AFS concept of a process authentication group is not actually implemented and enforced by the Linux kernel. That any process that is running as any UID is able to debug and access the memory of any other process. Therefore, it's possible to steal credentials between sessions. And as a result, it is not something which should be supported because it provides a false sense of security. The general concept in their mind is that anything, that credentials are the UID, and therefore any process running as a particular UID should have access to the same credentials no matter where they are in the box.
It's going to work so great with anything using kernel keyrings, including fscript, eCryptFS, Kerberos anything. Yeah.
Well, actually, if you're using MLS SE Linux, you can have the same user in a different context. So it's even in the Linux kernel to be able to do that with SE Linux. So I think that.
I don't think they like SE Linux.
Okay. I think I'm the last talk before a break, so